A box contains 20 coins in quarters and dimes worth $3.80. How much of each coin are there? Or how many of each coin are there? If it was 20 quarters, how much would it be worth? Let's just think about that for a minute. 20 quarters. If we have 20 quarters, each quarter is worth 25 cents, of course. So we can multiply that 25 cents or 0.25 in dollars times the 20 quarters, and we would get $5. If we had 20 quarters, then the total value would be $5. So that's more than what we have here. So it can't be all quarters. So if we had 20 dimes, that would be 10 cents each times 20, and that would give us $2. So if I had all dimes, then the total value would be $2. We're above that. So we have part quarters, part dimes. It's not all one or the other. So do you think we'll have more dimes or more quarters? Halfway between 5 and 2 is 2, there's 3, so $1.50, so $3.50. $3.50, I think, would be exactly the same number of quarters as dimes, 10 of each. So we could calculate how much money it would be if we had exactly the same number of quarters as we did dimes, 10 of each. Or we can just say, I think that it's going to be, I suspect it'll be exactly halfway. So 5 plus 2 divided by 2. So it's going to be 7 halves or $3.50. We're a little bit over that amount. I would guess that we have more quarters. Then it says solve the problem. So we need to figure out exactly what we do have. This is a mixture problem because we have a mix of dimes and quarters. We know we have 20 coins altogether, so quarters, the number of quarters plus the number of dimes is going to be 20. So I know I have 20 coins altogether, and the value is $3.80. Well, I can't just say quarters plus dimes is $3.80 because that's not going to take into account how much each coin is worth. But we have a clue right here where we did the 25 cents times how many of the coins we had. We'll do that for this full problem as well. So it'll be 0.25 times however many quarters we have plus 0.1 times how many dimes we have, or 0.10. It's the same thing. And when we do that, we get the value of $3.80, which is what we came up with, what we were given from the start. So this is my system. I would like to solve this first equation for, say, the Q, because I see there's no coefficient and it'll be very easy to solve for. So I'll put Q equals 20, and remember I need to subtract D from both sides. So 20 minus D. And that gives me a system that I can solve. I'll take that 20 minus D and put it in wherever I see a Q in the second equation, because that's what Q is equivalent to. And then I will have 0.25 times that 20 minus the D plus, and now I'm coming back to this part of the equation, plus 0.1 D equals 3.8. Now I can go ahead and distribute that 0.25, and 0.25 times 20 we already did up here, and that came to exactly 5. So I can write that, and then I have minus 0.25 D plus 0.1 D equals 3.8. I want to subtract 5 from both sides to move it over where the other constant is. And on my next step, I'd like to combine these two like terms. They both have a decimal value multiplied by D, so I can combine them together. I have negative 0.25 and a positive 0.1, so it's going to come to negative 0.15 D equals, And then 5, I have a 3.8 minus 5, negative 1.2. So that gives me a negative 1.2. And then I want to divide by that coefficient on the D, so negative 0.15 on both sides. And I have a negative divided by a negative, so I should get a positive answer, and I do. It is D equals 8. That means I have 8 dimes. If I have 8 dimes, how many quarters do I have? Well, remember we decided that quarters had to be 20 minus dimes, and that's from right here where we solved it. So we can use that to help us figure out the dimes. So quarters equals 20 minus 8. So quarters equals 12. So I have 8 dimes, 12 quarters, for a total of 20 coins. Okay, and there's a nice way to write out my answer. I can check that so quickly. I can take 8 times 0.1 plus 12 times 0.25, and I expect $3.80. So let's try it out. I get $3.80. So I know I got the right two numbers there. So there's my solution for that problem.